Hello, hello, and welcome to episode number 120, in which we're going to explore cluster mesh and DNS. Saw a really interesting blog in the eCHO News, and I'm going to be exploring that. But speaking of eCHO News, let me get my screen shared, and we will go check out the news of the day. And then we're going to play with all things cluster mesh, and that'll be fun too. All right. As usual, we have our HackMD. Oh, but I didn't share it yet. So if you were to go look for it, it would not be available. 120, save, published. Okay. All right. So it's there now. And let's go ahead and take a look at the news. So this is the most recent one. It's December 12th. It was announced. It was basically announcing the acquisition or the intent to acquire Cilium by Cisco and a bunch of other really interesting stuff. There's some great technical articles in here, including Hubble Series Part 3, which has been put together by Mr. Dean Lewis, really showing off a lot of really great stuff. If you are interested in checking out more of those, you can take a look at the blog. There's a bunch of other really good stuff in here, kind of around integrating with Hubble and these sorts of things. It's a really good series. Over the holiday break, we also had the Cilium Advent thing, which is pretty cool. And there's just been a lot of really great stuff happening. Unleashing the power of K3S for edge computing, deploying 3,000 in-store Kubernetes clusters. In part 1, lots of really big stuff happening there. The Advent dip code, I thought this was pretty neat. This is actually, is this the one? Oh, this is interesting. There's somebody else doing it. I didn't realize this, but there's somebody else doing an Advent of code leveraging eBPF, which I thought was pretty neat. I have also seen Liz get into this. I think she did this as well. I think on a most recent episode or something like that. Migrating from Metal LB to Cilium's IPAM, which is pretty cool stuff. I've just been playing with OpenShift and BGP this week, kind of exploring how all of that will work. OpenShift, Cilium, and BGP. And in this episode, we're going to explore L2 announcements. So it's another recent feature of Cilium is that it can actually do things like L2 announcement capabilities, which is actually, ironically, going to be, I think, pretty much exactly what's documented here. Oh, nice. Yeah, totally is. Funny. Yes, I'm going to be doing a lot of the same thing that is documented in this blog, but in my configuration. For cluster mesh. All right. What else do we have here? We have K-Mesh, high-performance service mesh data plane based on programmable kernel. Tarian, protect your applications running Kubernetes from malicious attacks by pre-registering your trusted process. Interesting. Lots of cool stuff happening. So this is actually the blog post that I saw, and I thought, let's just do an episode on this because I find it pretty interesting. So the idea behind this is that to enhance cluster mesh so that you can interconnect things back and forth between different clusters. To understand that problem a little bit more, what actually happens in cluster mesh by default is once you've created the mesh of the clusters, then each side of the mesh, both of the individual clusters, are able to understand how to communicate with any pod in the system, any service within the system. However, if you wanted to address elements in another cluster that were like in another namespace or called by a different service name or anything else like that, there's no actual DNS discovery that allows for the discovery of those services in another cluster. When you're routing that traffic, it is reachable that way, but it's not actually it's not known that way. So in this introduction, if you've ever fiddled, it basically lays out the same challenge. They've tried a few different things. So in our scenario here, they're deploying 2 different Kubernetes clusters, one with, and they don't have overlapping pod CIDRs. They have 2 different pod CIDRs. And then the stateful workload could be anything, a MongoDB cluster, for example, that needs to be replicated and stretched between multiple clusters. And say our workload needs to explicitly state in its configuration the other participating members, for example, in pseudocode. Now we have to make a few assumptions in the underlying infrastructure. Pod CIDRs must be unique between clusters, which we know already about Cluster Mesh. Cilium must be installed and Cluster Mesh enabled and set up. We're going to walk through that today. If you have any firewall, pardon me, my goodness. If you have any firewall, you have to open up the necessary holes. And then they get into Cilium with Core DNS. So Cilium Cluster Mesh is great. It's tightly integrated with other features to make Cilium a great CNI. Hubble network policies talking us up, which is awesome. However, maybe in the future they will add something like this. It's an interesting idea to specify the cluster when accessing a service. So there is no way to actually call from cluster A the pod member of 4 of a stateful workload in a headless service foo resides in cluster B, which is true because the DNS names are not propagated between clusters, right? There's no DNS propagation between them. So in Cluster Mesh, you have the ability to interact with the DNS servers on both sides of the clusters, but we don't wire anything up automatically for that. So our main goal is to have a proper way of calling member 4. That's a DNS entry in cluster B that we want to be able to access. So, and they've gone through a few different pieces of exploration. They looked at something like external DNS. They've looked at load balancer services. We already had DNS service, and there is already connectivity between the two sides. So the question becomes, like, how can they get the DNS names that are known in cluster B to be also known in cluster A? So that's an interesting question. So let's dig into that a little bit. The idea here was to expose the core DNS service, and there are plenty of different ways to do it. You could do it with a load balancer, with a node port. You could protect and restrict access however you like, so that cluster A will forward requests for cluster B to the cluster B core DNS, which again is routable and perfectly valid within Cluster Mesh. In this implementation, they've gone ahead and created a service of type node port, and they've exposed it. We're probably going to use a load balancer or try to use a load balancer. We'll see how it shakes out. Again, this is just an example. You could explore it in lots of ways. And then here is the interesting bit here inside of the configuration. So in the default configuration, this is actually where it's actually pointing at. Okay. Oh, interesting. Clever. Okay. So we can edit the default core DNS configuration of cluster A, which is by default, which is a config map named core DNS in the kube system namespace, and add the following snippet. And what's happening here is that we're forwarding to the node port, which makes me wonder. Yeah, I guess it probably, there might be another way to solve this problem, but we'll explore it today. We'll kind of dig into it, see how it works. And then the same for cluster B. Basically, what they're doing is adding 2 different other domains that can be queried by the cluster. And so they're saying if anything is trying to talk to domain name.cluster.b, then we want to rewrite the substring cluster B to service cluster.local, and we want to forward that to the service exposed on the other cluster, the DNS service on the other cluster. And we're going to round robin it. I don't get why 2.1 and 2.2 though, because if it's a node, I see the nodes themselves probably. Yeah, let's dig into it a little bit more. And then in here, if there's anything talking to cluster B or cluster A, then we're going to refer to that as service cluster local, and we're going to hit our own local configuration. In the same configuration would, with the opposite cluster forwarding is done for cluster B. And we've defined all of the stuff necessary to make all of this work. At this point, everything is set up. We can restart the core DNS pods in kubesystem namespace, and if the config map is correct, the pod will be ready in a matter of seconds, and then we're gonna get it going. So let's take a look at this. Let's see if we can get this to work. I'm actually pretty interested in how this would actually function. So let's get it going here. So I guess for this purpose, I'm going to bring up a couple of kind clusters. We're going to explore that way. So let's see. Kind, and then LC9. All right, so that looks like a good template for us. So let's make our first cluster. We're going to call that C1. This does not have Cilium installed yet, but we're just going to deploy the kind cluster. All right. So let's go ahead and create C2. Be our two clusters, C1 and C2. All right. KCTX, KCTX, C. Here we are on cluster 1. Let's just do our Cilium install. Dry run Helm values. Just drop that into C1. YAML. Dot to config. So this is, well, it still has both. Wow, interesting. I didn't think I thought filtering actually worked here, but I guess it doesn't. So it doesn't really matter too much. All right. So edit our values here. And we're going to do a couple things. We're going to enable L2 announcements. And what else are we going to do here? Let's see. Do I need anything else? Oh, we need the ID, of course. I think probably enough for now. So let's do install values. Pods. Context. What happened there? Where's that happening? Good. That was weird. Okay, anyway. The environment variable didn't get cleaned up because I removed the environment instead of, anyway, doesn't matter. It'll get pods. All right, good. So we'll do Cilium install. Values. Cilium status. Wait. On that, let's go ahead and install C2. Ah, just realized the problem. Anybody else realize the problem? Find cluster C2 equals C2 keep the C1 one. And change our pod slider so it doesn't conflict. do that. We're still using DNS, so we're just going to change that in the kind config. I don't remember what that parameter is. I do know that it's in networking. IP family, PS server address, blah blah blah, hot subnet, boink, copy. So it's 10.244 is a default to make this R5 R5 R5. There you go. Okay. Kind cluster kind create cluster name equals C2 config equals that can get us up with a different subnet, then we can keep going from there. All right. Okay, let's see here. I'll get /a still idling, which is good, and then we'll do Cilium install values. Values. All right, good to go. Get /a. Come on for a second. Let's check out cluster 1. Cluster 1 is up and running. It's using 10.244 as we suspected, and cluster 2 is still coming up. Come the cluster nodes. They proceed. Local path provisioners coming up. Okay. And 10.245 is used by this cluster, which is what we want. All right. Cilium Cluster Mesh enable context kind C1 server type. Oh, gotta finish up the load balance piece first. Okay. So CTX All right, so then let's take a look here. So this is Docker network inspect kind. So the subnet that we're using in here is 172.18.00.16. And we're all of our nodes are part of that first part of that network. These are the IP addresses that are being used here. So what I want to do, because I'm going to do an L2 load balancer, I want to pick two subnets that are in the same range but not in use by Docker. So because this is a 16, I'm going to use 100 and 200, 172.100 and 172.200/24. So for the next part, make a LB pool. And the way we're going to do that is we're going to create a Cilium load balancer pool. And because this is L2 announcement, that means that the network that it's a part of needs to be part of the same network as the hosts, effectively. 100/24. Cilium LB pool C2. Make this one 200. Now we have two different load balancer pools. And then the other thing we need is a Cilium policy that will expose these things. So let's go ahead and make that. Bam. Cilium L2 policy.yaml. Get these examples right off of the true. Basically the same policy. Cilium L2 policy C2. All right. Okay, and then you can get all apply-f. Cilium L2 policy. Cool. Oh. We will do policy. Cool. Same problem because I was copying and pasting. All right, so now in theory, plumbed. So let's go ahead and test it out real quick. 1 times C1, kubectl create deployment, image equals admin echo server port 80. Echo expose image echo load balancer. Services. Curl on the port that's exposed. There we go. All right, so that's working. We have load balancer type services. Things are working well. So let's just do the same validation, but on C2. Good. Both are serviced. You can see that the load balancer range used for C2 is 100, and the load balancer range used for C1 is 200. Oh, we got that backwards, but whatever, it doesn't matter. All right. So let's see. The next thing we need to do is Cilium Cluster Mesh enable. Service type. Load balancer. And this should deploy our Cluster Mesh API server. All right. So the status. API server is up. And Cluster Mesh. Connect. Context. Two. Cilium Cluster Mesh. Right, have our cluster mesh. So to dig a little more into what I was talking about before, let's take a look at Kernel get pods show wide. So here is our pod that we deployed, our echo pod that is doing our echo stuff. And we can see it's got a 10.244 address. So I'm going to go ahead and deploy onto Kind Cluster 2. And bash bash. It's on both. Context kind C2. This is basically just creating a little bash image, and we can throw curl on there and do neat stuff. So let's jump into kind C1. And get all ti dash bash git add curl. Works. Okay, so then we'll go ahead and we're on C1. So what I want to do is take a look at C2. I'm going to split my screen horizontally. Keep kernel get pause dash n. No, actually, context kind C2 dash O wide. So this is the IP of the echo server on kind C2. And if I were to do curl colon 8080, I can see that I'm able to talk to that guy. And we can see that the IP address, the request header, is 10245 because I'm on kind C2 and I'm talking to kind C1. Actually, that's 244.3.188. So that makes sense. Yeah. So there we go. We have Cluster Mesh up and running. So next, let's go back to our doc here and take a look at the blog post, and let's play with this idea of Cluster Mesh with DNS. So this gets into this piece of it. So what we want to do is we want to expose the DNS service between the two sides. And they're using a load balancer for this, but here's what I'm really wondering. Because you're using a node port mechanism for this and pointing at the node IPs, which would totally work. But what I'm wondering is, like, is there a way to do this with, like, the connectivity that already exists? And I think the problem is that you don't know what the IP address will be. But what if you used, yeah, there's no way to know, no way to address it without, there's no way to address it without knowing what the IPs are. The benefit of this is that it's easy to template, right? Because you know what the node IPs, and you know what the range will be. That's simple enough. Let's do that. Let's try this out because I'm super curious to see this work. This will expose on every host where, every host where, on every host port 53 on versus via a node port on 3053. So apply -f DNS node port. Now this is interesting because this is actually exposing the DNS service from one cluster to another. So this is a bit of an info leak. By default, it is not exposed. Probably a good idea in this particular case because we do want to expose this on two different clusters so we can refer to them independently. So now we have our node port exposed. Have it on the same context for kind C2. Nice. So now, oh, that's actually kind of interesting. Oh no, this is 3053. So it doesn't conflict. All right. So that's all working now. Good old get nodes. Fine. C1, I can use 1802 and 1803 for C2. I can use 1809 and 18010 or 11 and 12. All right. So let's go ahead and make the changes to our let's go back and look at these changes. I'm going to add the following snippet. So let's take a look at the configuration. I'm actually going to pull up another terminal here. eCHO mesh. Okay. Get all edit big map dash n keep system core DNS. There's already a defined .53, and what we're doing is we're adding more to it, which is fine. And then we're also going to define cluster B. So this means that every query for the fake zone cluster B will be handled by this configuration. This will substitute cluster B in the configuration with service cluster local that can be handled correctly by the remote core DNS. So let's go ahead and do this on the, so we're on cluster 1. Because .53 is kind of a fallback, we need to define anything that we want to change up ahead of it, right? So we'll do cluster.c2 colon. We'll open our bracket. Right. Copy this all. Paste it in there. Apparently this will not work. Okay. You know, another thing that we could do, if we cared about it, is we could actually make it so that the cluster name wasn't cluster.local. It could be cluster.c2 instead of cluster.local. It is interesting that they're renaming cluster C2. They're replacing cluster C2 with the string service.cluster.local. I'm not sure why service in this particular case. Well, let's go with it for now. And then we're going to change the IP addresses to point to cluster C2. So 18, 0, 11, 2.18.0.12. Something up in there? Now let's make sure those are the right IPs real quick. Those are 11 and 12, which will work. Okay. And then the next piece here is to add this piece. So let's do our rewrite. One. Local. You can see because they put an anchor line in here, Kubernetes cluster.local, they want those to be rewrite before that. And now we have some glare on my screen here. So that's all formatted correctly. It has everything we need. Go ahead and drop it in. Okay. And then let's go ahead and do the same on the other side. Context. See. DNS, context, kind. And then we'll put our prelude again in here. Boop. It's going to be cluster C2, or C1, cluster C1, so it's cluster local. It's going to be 172.18.200.8. No, sorry, 0.9. Good. We'll do our rewrite. And substring. One. Local. Up there. Map core DNS valid was not valid. Line 12 did not find expected key. That worked. All right. Okay, so now in theory, you kubectl exec ti -n. Actually, let's just take a look at that other QDNS piece. System. Kubectl get pods -n. System. The core DNS is operating. Context. Two. It reloaded based on the configuration change. That's a good thing. All right. Clear. All right, so let's try it out. Let's do kubectl exec ti bash. Oh, you know what? We got to define something first. So let's go ahead and actually, we already have something defined. Yeah. Host. Equals. Equals. No, my needles. What is that thing I'm looking for? Tools. There we go. Host. And if we were to do host, go. So we're getting this service, which is 1096. We do host echo.cluster.c1. Doesn't appear to be working. Turn this off. No longer, no longer enabled. Our IP address is this one, so if we do host, actually dig. Let's see. I want to know if the APR. APR 2443188. I think a way to deploy this is to put up my like per node thing. So let's play with that real quick. And then it's working, and we'll play with this a little bit more. So kubectl get config map -n kube system core DNS -OEML. Make sure that we got that correct. 1811, 1812. Yeah, I think maybe there's a typo. It is a typo. Yes. Because what's happening is it's shortened. All right, so we know what's happening here now. All right, so let's take a look at this next piece. So the next piece we want to do here, so this will actually not solve the services problem. This will only solve problems for pods that actually have a name. So let's make some pods that have a name, which I have here. 1 second. I've done this before. Code.sh. Yeah. So these guys set host names on pods, and they set a subdomain of net, which is what we want. Okay, so let's just deploy that. So let's do per node.sh kctx c2 ctx. Okay. Now the neat thing about this is now we have a bunch of pods on both sides that have domain names that are known about by each side, right? And so if we jump back into our cluster, we can prove that all of this is working. CTX, C1, kubectl, exec, ti, bash. Actually, before I do that, I should actually show you what it is that that's doing, because it's kind of interesting. Okay, so cat vanillium node.sh. So what this is doing, it's a little script that iterates over and creates a bunch of individual pods. And each individual pod, I'm doing a little bit of an overrun or an override of the configuration, and I'm configuring this so that each individual pod has a host name and a subnet configured on it. And part of the and we're doing this for every node in the cluster. So for every worker node, we're going to create one net pod. Actually, we're going to create two net pods, one called net1 and one called net2. And then we're going to give them each host names, and they're all going to be part of the same subdomain net. So that's actually pretty neat. So now if I were to do kubectl get pods, we can see that we've created a bunch, or we're in the process of creating a bunch of pods. Let's wait for them to get done. And I think we're going to need to edit our config map, because right now this would only match on services, which is not particularly what we want. It's taking a second to pull this image. How big is Maui-Land debug? Docker full Maui-Land debug. Oh wow, 200 gig, 200 meg. All right, I should probably slim this thing down a bit. Fine. How big is that one? What? Did I type it wrong? eCHO. way faster. There. All right. Okay, so we're now up and running. So now kernel exit bash page that one C1 B1. And then what I'm trying to figure out is whether I could do cluster.c1. I think that's failing because it's not a service. So let's do it again, and we'll do kubectl edit config map dash n system core DNS. And we will change. Oh, bummer. Change the same thing in the other cluster. This one actually survived. Weird. Where is that then? Oh, that's why. Okay. Default SVC cluster.c1. C2. Oh, that's not on C2. That is. All right. That is neat. Okay, so the DNS resolution is currently working all the way across for any pods with a name. And if the pod doesn't have a name, then there's no DNS resolution for it. the point that I made earlier is this doesn't solve services, right? So if I were to do curl engine echo default dot svc dot c1, local, which works. C1 should work, but it doesn't. Not sure why at the moment. It's not a typo. I guess maybe what I need to do is actually go back to the typo because of the way that config map actually works. Otherwise, I don't think it'll actually match. Is that working again? If I try and curl them, this one should fail because there's no way for me to actually get over there. The other one should also failing, even though it's defined. Curl that. Wow, trippy. What if we put that typo back in place again? Or fix the typo once more, see what happens. I mean, you cannot resolve host. I can resolve it, right? That's neat. It's giving me a resolution, but it's not letting me curl it. It resolves every time. That's a neat problem. Not sure what the problem is there. Anyway, we have proven that DNS works across the different clusters. We're able to resolve things, but for some reason, we're not able to curl them using this name. That seems a surprise to me. But we can actually like interact with things on the other side, right? So curl that, like we did prove out that nice. Yeah, that's pretty fun. Let's actually show it. Cool. All right. Well, I hope you all thought this was pretty interesting, and I hope you find it fascinating. I know I do, and I am looking forward to our next episode. If you have ideas about it, or if you have something you want me to explore next, do let me know. Otherwise, have an awesome weekend, and I will see you all next time. So thanks for tuning in, and enjoy your weekend.